In this video, we're going to look at how to take data from, say, your smartwatch and map it out so you can analyze movement from one of your devices, from a phone, from a smartwatch. So, for example, if you're pulling from a smartwatch or an Apple phone, you can export your, under health data, you can export your data, and it is a GPX file. So what we're going to do is we're going to take a GPX file and we're going to convert it so that we can have a table of data. And what we really want is longitude and latitude. And the benefit of this data, of course, is it also has speed. And so we can look at how quickly we're moving, we can look where we're moving, and it plots it based on time. And we're going to put that on a map. So if you want to work along with us, then you will find the workbook here at drstephpowers.github.io/BIA. And we are working through the workbook here called Reality Mining. So click here, it opens in GitHub, then open in Google Colab, save a copy, and then you can start editing in there. When you click into Google Colab, you'll also find the relevant files so that you can work with these files before you start, taking your own files from your iPhone or smartwatch. So let's look at how this works. All right, so if we're going to be pulling information from a phone or a smartwatch in terms of tracking our data, we're going to need a package called GPXPY. So the first thing we're going to do is install that package there. And then in this case, the file I've put into my Google Drive, or it's also in GitHub. So what you'll want to do is you'll want to download the file from GitHub and put it into your Google Drive, which means you'll need to link your copy of your Python workbook with your Google Drive so that you can get access to this file or your own files if you're pulling them out of your own device. So we're going to need pandas as PD, we're going to need that GPXPY and GPXPY.GPX. And that's because the file that we have here is called a GPX file. So if you go into if you have an Apple phone and you have health data, go into the health data, you can actually export your health data. And what it does, it will export a bunch of GPX files. If you had your watch, if you turned on outdoor walk, it tracks your path. And so what we're going to look at is we're going to look at an outdoor walk from a smartwatch. All right, so we've imported our packages. The next thing we need here is we need to use this function to convert this GPX file to something we can analyze. And so it's basically just going to take that GPX file and separate it out into its parts, into tracks and segments. And it's going to identify points and create these columns here: longitude, latitude, altitude, time, and speed. So you don't need to touch anything from this. This is all kind of pre-packaged for anyone who wants to export from GPX into a data frame so that we can start doing our analysis. So what we'll do is we'll call this process GPX to DF. And we are going to then locate our GPX file. In this case, we're going to be analyzing Route 719. And it's going to output a data frame we'll call GPX_DF. And then it's going to output points. So in case it's identifying particular locations on your walk. So let's port that in. And once that has converted our GPX file into something we can actually use, we can take a look at the table here and see what it has created. So for this particular walk, it has the longitude and the latitude, the altitude, the time that the walk happened, and the speed that we went. So we're just looking here at the top of this. Now it also has output for points. And so these points you can see are longitude and latitudes for where it thinks might be key items along the route. So let's take a look at what we can do with this. And the reason for the points is that you could add names. So if you if you wanted to mark that a certain point or location was identified on your map with a particular name attached to it, that's why it has that second output. All right, we're going to use a package called Folium to do our graphing, and we're going to create a Folium map. The location is going to be so first we have to figure out where to center our graph, our map. So what we're doing first is we're taking the average of the latitude, the average of the longitude, and that's where it's going to focus our graph, because these are interactive and we can zoom in and zoom out. So we just need to start by having a point generally nearby to where our data is located. So we're going to do that based on the average longitude and latitude. And then we're going to have a tile here. You can leave that. That just tells you what kind of map we're looking at. And then what we're going to do is so what that does is just creates an empty map in our area. And now what we want to do is we want to create points on this map. And those points are going to come from iterating through the rows of our table. And we're looking at the index and the row. And we're going to put a marker. It's going to be a circle marker. And that marker is going to be based on the latitude and the longitude of that particular point. So if I just go back to this data here, what you can see is it's going to go through each of these rows based on that index, and it's going to take the latitude and the longitude and put a dot at that location. That's what we're doing in this loop here. Okay, and you can specify how big that circle is. That's the last part here, and we're adding these markers to M. So the first thing we had to do was create our map, and now we're adding pieces to our map. So now when we say show us the map, it will not only be located where we told it to be centered, but it will also have our data points. Now it is an interactive graph. We can zoom in and out. You can specify the level of zoom so that you don't have to immediately zoom in or out. But here I don't think I specified, and so because of that, it was way zoomed out. So if you want to add that, how about in some other ones here? Zoom start, yeah. So we can set a zoom start if you want to not have it be way zoomed out when we go. So that would go here in this original creation here. Zoom start. The higher the number, the more zoomed in. The lower the number, the more zoomed out. So you can zoom out and be the entire world. All right, let's see how a 14 works. So we can see here that there's a hike, and it probably could have zoomed in even a bit more. And what we see in this particular case, I zoomed in so we could see it better, and then I can't fit it all on my screen, that this is a particular hike in Washington State around Mowich Lake. And so you can see where we walked, and when we paused the watch that was tracking our hike. So this is mapping out where we are going on our particular trip. You could add color to this map. So notice it was all blue, but we could actually add colors to this map to indicate the speed. So for example, let's say that we're using a device in our company vehicles, and we want to not only show the routes they were taking, but also the speed they were driving. And so we would want to show on the maps a color code for the speed. So to do that, we're going to need from matplotlib to import CM. And this definition here is just going to give us a range of different colors. Okay. So this color mapper, RGB values, what this allows us to do is actually attach colors to different speeds or whatever the variable is. So you need a numerical, interval ratio type variable that you're dealing with here, that is speed. And then all this code here is doing is basically letting us attach colors to it. And so the Civitas is a color scheme that is supposed to be more beneficial to people who are, for example, colorblind. So it's often used. And then the rest of the code, you can leave it as is. It is simply creating that ability to map. So the first part that comes in here is the part where we say, okay, what are we mapping the colors to? And so this part here says this GPX_DF, that's the name of our table, and our variable is speed. That's what we're going to be mapping the colors to. Okay. And so these are all settings to make sure that you have multiple colors appear. So except for that part where you designate what is the variable that's going to get the different color codes, the rest of it you can leave as is. And then what we're going to do is we're going to create our Folium map. Same thing as before, center the map on the average latitude and longitude of our data. We can set the zoom level, so maybe the zoom level needs to be a little bit higher. And we will start by creating the map. And then what we're going to do is we are going to add our markers, and we are going to have the points instead of the longitude and latitude. So the points are what works for creating the speed. And you'll notice when you look in it, it's one variable where it's already put longitude and latitude together as opposed to separate columns. So we're going to go through and we'll use the speed, we'll use the colors we just created, and we'll use the points. And then we will put circles on the graph where the location is the point, the radius 1.25, that's how big your circles are. And then we are going to use speed and our colors. So let's do that. And then let's create it. And so what we have now is you can see that we have blue and green shades, and though you can see then where we walked faster, so darker colors for walking faster, lighter colors for walking slower. And so you can see, for example, walking along, slow down here to take a look, decided we were going to stay and take some photos, pause the watch, and then turn the watch back on and keep walking. But so you can see here, there are different colors for how fast we were going through particular different ones. So you can add that color and you can change that color scheme to match colors that are meaningful to you. So here's a chance. You'll find in GitHub there is another GPX file, this one Route 704. So here's a chance to figure out, one, where did we go on our vacation, and see if you can lay it out as a map and add the colors to indicate speed.